Hello, students.
Hello, sir.
Good morning.
Good morning, sir.
How are you?
How are you doing, sir?
It's well with you.
Yes, sir.
So, this is Extreme Scientifics. So, this is Extreme Scientifics. Today, we are going to do a lot of work on chemistry. What do I call it? Chemistry. So, I'm going to ask you, what is chemistry? What do you understand by the word chemistry? Yeah. What do you understand by the word chemistry? Please be audible. Okay? I'm listening. That describe the property and use of matter. That describe the properties of what? Matter. Any other person, please? Then you can help us. Yes. Components and principles that matter undergoes. In what way? The chemistry study matter, okay?
The studies matter. We believe it's it is how we develop the studies matter.
Clap for him, fight. The way matter behaves, beauty of matter. Oh, that's nice. Any other person, please? At least you are giving me hope. Yeah. Any other person, please? Yeah, sure. But please be audible because of our audience. Yeah?
As the branch of pure science
Okay?
that deals with the study of structure and property.
Of what? Structure and properties of what? Of matter. You can never talk about chemistry without discussing what's called matter. You know what I'm saying? Because start with what? Matter. And end with what? Matter. And what is matter? Matter is anything that has and what? Let's correct something. Matter is anything that has what? And what? Good. As you are sitting down, you're a what? You're a matter. As far as chemistry is concerned. Right? As far as chemistry is concerned, you are a mass. Are you understanding? Good. And as far as chemistry is concerned, You occupy space. Yes or no?
Yes, sir.
There's something called BMI. BMI means body mass index. BMI. Body mass index. So, as far as science is concerned, the matter, you are occupying space. Your body has mass. And it's occupying what? Occupying space. So, it is matter that leads us to what is called elements in chemistry. Matter leads us to what is called what? Elements. So, what is an element?
Element and substance
Okay.
that cannot be put into simple elements by the chemical reaction.
Good. Clap for him, please. Again. Clap for him. So elements are substances which cannot be broken into simpler substances by ordinary chemical reaction. Why are they saying that? On and on. If something is an element, you can't break it into other words, elements, using ordinary chemical reaction. On and on, on and on. But when you now enter into the topics called radioactivity, you can now see that an element can split into other words, elements, but not through ordinary chemical reaction. Are you understand what I'm saying?
Yes, sir.
So, it's only in radioactivity that's why they put the word under ordinary chemical reaction. You can't split an element. But under radioactivity, when we get to that is in do it properly, you can split an element into different parts. For example, you can split uranium 235 or uranium 238 and uranium 482 or so. Can split it into different parts. So that's why we have what's called nuclear fission and nuclear fusion. Fusion means you split it. Fusion means it's what? It fuses. So it can either explode or what? Implode. Are you understand what I'm saying?
Yes, sir.
So as it does it is now split, say fission or splitting now. As it's splitting, it's coming to different elements according to its half-life. Don't worry, when we get to radioactivity, we'll deal with that. But on the norm, an element will not split under ordinary chemical reaction into another element. It won't. Here's what I'm saying.
Yes, sir.
It's what? It won't. But under radioactivity, it will. Please get that in the front of your mind. So as you are defining elements as a substance that will not be able to split, notice that in radioactivity it will what?
Yes.
So now when I say these things are elements, we have how many elements? How many elements did we have?
Ah,
How many elements did we have?
one,
Eh? 118. Good, clap for me. From hydrogen to unobtainium. What I call it?
hydrogen to oxygen.
Again.
From hydrogen to oxygen.
So from hydrogen to unobtainium, we have 100 and what? So there's something called periodic table. So we have hydrogen, helium, lithium, beryllium, boron, carbon. We reach the actinide and the lactinide series. Are you understand what I'm saying? Till you reach the californium, rubidium, all this polonium, uranium, bacanium, curium, einsteinium. Yeah. Eh?
Emmanuel.
Germania? No, Germania is not a radioactive element. Germania belongs to the group called, if I'm correct, um, they call them one name that's in this. Then we see silicon, germanium, uh, gallium, thallium, like that. We follow one after the other. We call them one name. Anyway, you know something. But it does not belong to radioactive. So two things that belong to radioactive group are the actinide and the lactinide series. So from this include all this, but all these germanium, silicon, and the rest, they belong to another group entirely. You know, in the periodic table, we have different lists. I have my periodic table. You know, I'm not treating it today. It's a particular subject topic of this one. I understand what I'm saying. It's a what? So you can notice, did you see me any open any book at the moment? They are what? They are there. That's how you too have to have it in there. Are you understanding me?
Yes, sir.
That's a scientist. If I start writing notes, you write. No, wait a minute. You should know what you are writing. So when you got, if you maybe you enter into let's say this lab that you dress like somebody going to the moon, will you be holding book there? No, you won't be doing that. Everything will be digitized. Are you understand what I'm saying? And you too, you have something upstairs there, so that you know what you are dealing with. Are you understanding me? So, there's time for you to write, you write, but you must know. It must be part and parcel of you to know what you are dealing with. Are you understanding me?
Yes, sir.
So you must know hydrogen, you must know the characteristics, you must know helium, you must know its behavior, you must know lithium. In fact, everything that you are seeing every day, you must know which element that is built with. So you must know the elements. I understand what I'm saying.
Yes, sir.
So, of hydrogen, helium, lithium, beryllium, boron, carbon. So you must know all those things by heart. Are you understanding me?
Yes, sir.
Good. So as I'm saying, the first I told you to list the first 20 elements. I will list it right here. I will give you a logic how you can use to be remembering all these things. So there's something I want to teach you. If I start writing, you listen very well. So, you coming?
Eli.
What's that? Eh?
Aaron.
Good.
Glory.
Neon. Neon.
Eh?
Neon. Sodium.
Okay.
Magnesium.
Magnesium.
Aluminium.
Aluminium.
What's the specific for it?
Mg.
Energy.
Aluminium. A. L.
Silicon. SI.
Okay.
Phosphorus.
K. K.
Okay.
Okay. Sulfur. No, sir, phosphorus is pH.
Oh, sorry. Okay.
Sulfur X. Fluorine. Argon. Argon. Ar. Potassium. K. Calcium.
Can you see now?
Yes, sir.
They just list the what? 20 elements. They just listed the what? 20 elements. Hello, let big boys come near our farm. Nay, no, man. Alabi said people should come and cut cow. Sorry, Alabi says people should cut and kill cow. Can we try it? Let's go. Hello, let big boys come near our farm. Nay, no, man. Alabi says people should cut and kill cow. From hydrogen to what? So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. That was the first 20 elements. That's the first 20
Elements.
That's the first 20
Elements.
Good. So, like as a scientist, you work smart. What did I say? You work smart. So, now,
15. Give that.
So, as we are saying, all these elements, you see it on a daily basis in the world. What did I say?
You see,
all the living in the world.
One way or the other, you use hydrogen. Can somebody tell me where we can find hydrogen? Yes? In water. Is one of the components of what? So can you give us the formula?
H2O. H2O.
H2. Good. Hydrogen what?
Oxygen.
So these are the components that form water. So you see two mole of hydrogen combining with one mole of what? Oxygen. Good. The next one we have helium. Where did you notice? Where did you see helium? This element. Helium.
So, how do you resources?
On this planet, the most simplest thing that you can find helium. Eh? On Earth, this on Earth. You've even played with this several times.
Sand.
No.
Not water.
Balloon. You know that what's inside that when you play the what was it to make that balloon come out? No, the listen. No, it's not spit. It's helium. When you blow a balloon, and also weather balloon. Have you ever called weather balloon?
That's all it's
They use helium. Weather balloon. Let's go to the next one. Lithium. Where can you find lithium? You use this every day. You don't know. You use it daily. If I tell you, you will shout, ah! In fact, one of you wear something, and that is the power that's that. What do you think that thing can be?
clothes.
I said, the thing power something. Do you have any power in your clothes? Eh? Oh my god. Who did I ask time from?
Oh, clock.
Digital clock. What do you think power is? Lithium battery. Most of Galileo Galilei, one of the Renaissance great scientists that work on that used his telescope to look at the moon for the first time and proposed theory of orbit of the Earth around the sun. He says something. Galileo Galilei says you can never teach someone something. Rather, you make the person to understand what he or she has been doing. You bring to the person's understanding what he or she has been used to. You've been wearing a digital watch. I know you didn't know the thing that power that it is what? Lithium battery. So what they use in making that battery is called what? Lithium. Say lithium. Lithium. So let's go to the next one. Beryllium. Where are we going to see beryllium? What point is? There's something called beryllium. Yeah. The next one we have boron. Where are we going to see boron? Where do you think you can find boron? It is not that too much common. You can find it in a very good place for life. I found boron. Good? No.
In part of the mineral resources.
Yeah, it can react with this. You can't find bonds.
Limestone.
You are closer. You can find all this your thousand. You visit on this. You are closer. You are closer. Clap for it, please. Don't let it. Don't let the shark hear you. Are you understand what I'm saying? So you can find it as a kind of molecular structure of some, let's say limestone and some other stones. Are you understanding me?
Yes, sir.
Later they now separate it. This is some kind of a separated technique. Are you understanding me?
Yes, sir.
Then the next one is carbon. Where do you think you can find carbon? Yourself, you are made of carbon. That yam you are eating is what? That rice you ate before you come to lab is what? That cereals you eat is called what? It's made of carbon. When we enter hydrocarbon, you understand better. So mostly everything we see is what? Carbon. Are you understanding me?
Yes, sir.
So everything around us, our plant, the plants, even the air you are breathing out is what?
Carbon.
Carbon.
Carbon dioxide.
Carbon dioxide. The smoke coming out from the exhaust is what?
Carbon dioxide.
It's carbon dioxide. That's why you have to be very careful when you are with carbon dioxide. It can kill. You know, when you enter all these big motor, all those molo of this. How many of you have entered molo before?
Mole.
Yeah. This I won't call it luxurious box. All those box of those days. Immediately when you enter, you've not experienced such a thing. You notice that if you are maybe you are sitting at the back seat where a lot of carbon is coming out, you will notice something. You start sleeping, feeling dizzy, right?
Yes, sir.
You start to feel dizzy. When you know you start to sleep. Why? Because of what? Carbon that is coming from that exhaust. Are you understanding me?
Yes, sir.
Carbon that is what? Coming from that exhaust. So you have to be very careful with some toxic carbon. You see the charcoal, right?
Yes, sir.
And funny thing about carbon can do what is called allotrophy. What I got?
Allotrophy.
It's called allotrophy of what? Carbon. That is, it can catenate. What did I mean? Good. Even the money you are spending, what make that money, polymer money, is what? Carbon catenation. They polymerize the carbon. Are you understand what I'm saying?
Yes, sir.
Uh-huh. Carbon has a way to come to different things. You can have it as a diamond, you can have it as a graphite, you can have it as a this because it's allotropes of what? Carbon. We'll get there. We'll go deeply into that. How many of you wait a minute? How many of you have got this book called Oseya Ababi?
Huh?
Oseya Ababi chemistry by Oseya Ababi. How many of you have it? Huh? It's not
Essential.
no, not essential. The girl wrote chemistry. And I write Ababi. Oseya Ababi. As a scientist, that's the first book they take to get first. So, they say Yo Ababi. And so that was the first this is the third in Nigeria. We try to get this book. This I want to go and find it if it's still in print. I'll find it. In my time now, like we study using say yeah, before comprehensive chemistry to become essential chemistry. This book is the reading. I understand what I'm saying?
Yes,
So
sir.
we're not talking about all that big advanced chemistry. So it explains about it explains about allotropes of carbon. Allotrope of what? Of carbon. Please, what is time? Time, please. Okay. So that is that for you concerning chemistry. So carbon has different kind of allotropes. I understand. It can form a very strong hard bond like diamond or like other quartz crystals. It can form another this like charcoal or graphite. I understand what I'm saying.
Yes, yes,
That
sir.
is carbon. It's very interesting. No? And it can also form liquid like the hydrocarbons. The alkane, alkyne, and this thing, all this hydrocarbon chemistry. The methane, the propane. We use this every day. Use it in your perfume, you use to cook. That gas
Yes,
that you're using is just propane, methane gas, all those stuff. So that's carbon. Are you understanding me?
Yes, sir.
So you use it day by day. You spray your perfume, is there too. You understand me? So when we get there in hydrocarbon, you see different list of carbon. In fact, they even make sure that they separate a particular topic for it. A very long explanation and discussion about carbon. The petrol we are using is carbon. Bitumen, all this you get from crude oil, petrol, gas, oil and gas, all this bitumen, all this propane gas, different kind of things that we are using as fuel. Are you understand what I'm saying? Yeah, all those methylated spirits, including alcohol, which you call carcine, is carbon. Are you understand what I'm saying?
yes, sir.
They are all what?
Yeah,
Carbon. Alcohol is a carbon. That punk alcohol that some people will drink that will slice their intestine. That thing you can use this. They use in ancient times to light this in the wick. They put inside this thing. You can light a wick. Next time I'm saying you can use to power the car. I understand me. So these are the history of carbon. So bro, next one is what nitrogen. Where can we get nitrogen?
Like gas.
No, I know nitrogen is gas, but you can't get it from just gas. Any other gas. Where did they use nitrogen? And how does nitrogen texture look like? I know it's a gas, but how does it look like? If you touch like nitrogen, how will you feel? Eh? Very cold. It's the kind of gas that you want in your life. You must say, no, this is nice. Let me use my hand to steer it. Your hand is what? It's gone. It's what?
Good.
That hand is gone. So nitrogen is a very cold gas. It's a gas, oh.
Like fridge.
Yes, like which. In fact, one of the components that are using this thing, some freezer, some this is was nitrogen. So it's very cold. They use it in cold room too. Nitrogen gas. They also use it as fertilizer. I understand what I'm saying.
Yes, sir.
Even before you come this morning, if you eat beans, you've ate nitrogen is part of this thing. Beans which you eat. So the next one is oxygen. Where will you find oxygen?
That's what they have to sugar and gas.
Huh?
Our plants.
Our plant, our trees.
Good. The plant, the trees, the hospitals.
Yes.
And what do we breathe in?
Oxygen.
Are you sure it's oxygen we breathe in?
Yes. We talked about.
We breathe in air. Alright? And when you say air is a constituent of like 3 or 4 gases. What did I say?
Hey, this is the gases.
If you breathe oxygen directly, and that is my brother is looking me gentle, you will be more docile than what is my brother. What do I mean by docile? Look at me. You want to say you back up, you don't be docile. Oxygen will make you feel cool. If you go straight into your brain and cool your what? Your brain. Have you entered your brain before? Have you ever entered your brain before? inside the airplane. Yeah. Do you notice something? If the airplane is moving, maybe there's turbulence and maybe something happened in there. What do you think will first come down?
Let's come down.
Uh, something will come down. So what's that thing?
Like oxygen max.
Good. Clap for him, please. Clap for him. Clap for him. Clap for him. Clap for him. Oxygen
Max.
max. Why oxygen max?
Oxygen max is actually used when, let's see, the air gravity air is in the plane, so you have to put it in to be able to survive.
God bless you. Clap for him, please. You know, when aeroplane fly, it will reach a region. There's a region called ionosphere. There's another region called region of the cloud. That is, in that place, there's no oxygen. I understand what I'm saying. The oxygen there is so tiny. If you go more into the outer space, you enter into outer space where there's no oxygen at what at all. But as the airplane is going, if there's any issue with this thing, there will be no air. So that breathing mass will come down, you put it in your nose. And one more thing that is doing is that as you are breathing in oxygen, direct oxygen, oxygen, what will happen? You'll be gentle. You'll be just like a lamb. You will calm down. Are you understand what I'm saying? That's why in hospital they use oxygen. The patient will what? Will relax. It will relax your brain, relax all your nerves. So that's oxygen for you. So you mostly see it in the hospital too. You see it around from plants. The plants receive our own carbon dioxide and give us what? Oxygen. So they take carbon. I understand what I'm saying. Good. The next one we have what is called fluorine. Where can you find fluorine in your daily products? Okay, so how many minutes do you want? 10 minutes. So where can you find fluorine? Where can you find fluorine? In your toothpaste. Fluorine is the fluoride. So we have neon. Where can you find neon? Neon. No. You see it in all those sign writing. These are lights. This sign writing. This hotel light. Or this. That company inside that fluorescent bulb is what?
Neon.
Different red color. That's enough. Then sodium. Where can you find sodium?
Salt.
Salt. Good. Magnesium too is also a salt. Magnesium salt. But if you don't take this kind of salt, you don't give it until you want it to. Aluminium. As you are coming, you saw aluminium this thing.
Yes, sir.
Used for door, all this stuff. The next one, silicon. Your sand. Your what?
Sand.
So the sand is made up of silicon oxide. That's your sand. The next one we have phosphorus. Where can you find phosphorus? I'll give you as assignment. Where can you find sulfur? I'll give you as assignment. Where can you find chlorine? I'll give you as assignment. Where can you find argon? I'll give you as assignment. Where can you find potassium? I'll give you as assignment. And where can you find calcium?
Calcium can be found
In what?
in gold.
Clap for him, please. Clap for him. Calcium can be found in the what? Please, with this 5 minutes, there's something I want you to explain to this, my brother. Look at it. This is called the what?
Right?
No, this is not the paper. This is the burette. What do I call it?
Burette.
Let me open it. Because you don't want to do this. Hello. Open that. Let me bring that cutter. Okay. So, hello. If when you get home, if you can see Maybe rats, you bring it to school, tell them down it, you use it.
I like
So this is
is that like
either dead or alive. You bring it, but let it be fresh. You put it inside formalin. And let's come out. It's enough. Okay. So this is the bread. What is this called?
bread?
Look at it very well. I think my slide is 5 minutes. It's going to be this. This is the what? Look at it. This is the bread. So you put the chemical there. So you can, this is what you are going to use to control the fluids. Fluids. So this is what you are going to use to what? To control it. Understand? So we add this thing here like this. You understand? So you will be controlling it. When you are doing your volumetric analysis. What do I call it? Volumetric analysis. So you measure it, but it is calibrated. It is well calibrated. So you be putting it down like that. You put it down like that. So you do like this. Can you see? Can you see? This is how you see. So let me read from that one. This is your pipette. What do I call it? Pipette. This is your pipette. Say pipette. Pipette. So what is the work of the pipette? You used to, is it only to measure? What's the major use of pipette?
Gauge.
Good. So what?
Gauge.
You because you are dealing with acid and base. You know what I'm saying? Acid, base, and salt. When acid reacts with base, it gives you what? Salt. You know what I'm saying? So the end product is what? Salt. Are you understanding me? So and some other byproducts and water and the rest. So you can't just begin to use your hand to be getting that acid. It's corrosive. It will burn you. So you use the pipette to draw these things. You draw it like this, and you put it inside the conical flask. Let me show you. Inside locket, you are the first person who will do this one. So you put inside there. After the space here. So as you are sucking the measure, you are looking at it. Once it reach here or here, you use this and hold it like this. You take it to another is when you are doing it. I understand what I'm saying.
Yes,
So, there's also this glassware. This is cylinder. Look at it. This one too is called measuring cylinder. Used to measure. I understand what I'm saying. So when we enter into chemistry program, we are going to use it. So I'm just introducing you. So you that you want to do exam, practical exam, they will give you this thing. They give you. So you measure it. See that it is well calibrated. So you measure it. You have to be very careful when you are handling these glasswares. You understand me? They are further in all way, but they are useful for the classical work. So these are the things. This one is text 2. Let's give you some minutes, please. This is test. This is what?
Yes.
Are you seeing it?
Yes, sir.
This is the test tube. So when you are using it, there's something called test tube rack. What do I call it?
Yes, sir.
What do I call it?
Yes, sir.
Let me show you. This is the test tube rack. What do I call it?
Yes, sir.
Look at it. There's a test tube. There's a test tube rack. If you are not using it, you put it here like this. Can you see it?
Yes, sir.
Yes. And there are different things. You can see that this one is small. There are some tests that are bigger than it. Than this. Yes, this is used for those other big tests. So you still get more. So these are the words that you're going to see in chemistry lab. Other ones are coming separately from all this lab. But this is how those things that you're going to find in the process of chemical laboratory. So did you understand?
Yes, sir.
So is there any question before we call it today? Any question? Yeah. You listening? Huh? Huh? Neon, what's happened to Neon? You didn't really understand Neon. Good. Neon belongs to a particular group in chemistry, in this periodic table. We have neon, argon, radon. They've completed, they are gaseous anyway, but they've completed their octet rule. What do I call it? When we enter deep into chemistry, you understand? They fill their orbital shell. You understand what I'm saying? So they can't react. For example, somebody that is well satisfied, they won't what? They won't react. So this element called neon is part of those group. So where you see them you see that they use this neon gas is all these signposts. If you go to a hotel, you see those called multicolor. This is something maybe orange, it may be green, it may be purple. So those lights that you saw that they use as a signpost. Maybe you want to enter a hotel or you want to enter pharmacies. So that gas inside is called neon. You understand? It's called neon gas. It's a gas. But it has completed its octet rules. Are you understand what I'm saying? It's called inert gas. What do I call it? Inert. Inert gas. Again, what do I call it?
Inert gas.
Inert gas. Don't forget it. So it's not only neon, we have argon. This guy, where is it? This guy, argon, is also part of the family of what? Neon. I understand what I'm saying.
Yes,
Where
sir.
do you see people using argon? Do you know all those bulb of those days that used to show bright light like the sun? That used to show yellow bright light. And if you touch the bulb, it's very hot.
Yes.
That is what? Argon. That filament is called what? Argon. This that they put inside it. Sorry, we have concrete filament, but that gas inside it is called what? Argon. I understand what I'm saying. So yes, this is where they use all those things. Any other question before we go? Time, please. Another question, please. Yeah. Another one. Body mass index. What happened to it? Body mass index. For example, now before anybody will just give you maybe injection and all those stuff, they should study your what? Body mass index. They will measure it. But if they go and give you a dose that's for fat person, what do you think will happen to you? What do you think will happen? The person may die. So they will check your body mass index. If they want to take you, maybe you have infection. Maybe someone have infection. So they will, before they begin to give you all those, you need to know your body mass index. Maybe a pregnant woman just gave birth to a baby, they will check the body mass index of that baby before they start giving that baby what? A dose. You understand what I'm saying? So everybody, that's what they say, they will check you measure your weight. It's part of the body mass index. So they'll measure it. They'll not do some calculation to get your body mass index. You understand?
Yes.
Good. Any other one? You are looking in your question. Are you sure? You look like boy genius, Jimmy Neutron. And what was that cartoon before? You say with that guy. He's a genius. I pray that God will make you a genius. Say amen.
Amen.
God bless you. So if there's without any further ado, let's call it a day or 2 days or a day.
Thank you, sir.
Yes.